In this video, we're going to take a look at formula and then how we use formula to get what we call balanced equations. So the formula, we'll first of all look at the formula of elements. Now, elements, as you may remember, consist of one type of atom and can't be broken into anything simpler by chemical means. So here's a representation of sodium, here's potassium, different size of atoms, and they've got a slightly different makeup, so that's why we represent them there just with different colors just to represent that. And then lithium would be again a different size of atom again. So these are representing three different metals that are parts of the elements. Now, because the atoms are all identical, so they've only one type of atom, the symbol for the majority of elements is simply the same as what appears in the periodic table. So the symbol for sodium is Na, symbol for potassium is K, symbol for lithium is Li. Noble gases, that right-hand column on the periodic table, consists of helium, neon, argon, krypton, xenon, radon. And when it comes to the noble gases, they have no chemical reactions, and they don't want to join with any other atoms. So they simply go around as gases. So helium is simply one type of atom, He atoms, and therefore its formed as He. Neon, one type of atom, Ne. Argon, one type of atom, Ar. So the vast majority of elements simply have the same formula as their symbol in the periodic table. Now, a few of them, and we'll see the pattern in a moment where they appear in the periodic table, have actually got two atoms joined together. And this is what we call a molecule. We talked a little bit about that in year 9. So the definition of a molecule is two or more atoms chemically joined together. Two or more atoms joined together. So this is a molecule of oxygen, and we'll come down to it in a moment. There's a molecule of hydrogen, nitrogen, and so on. So these all represent molecules. Now, molecules are different from atoms. Remember, atoms couldn't be made any simpler. They were the smallest parts of elements, so they couldn't be made any smaller. But a molecule is two of them joined together. So single atoms are called atoms, and then when you join two or more of them together, they become molecules. Now, to represent them, you're familiar with, for example, oxygen being O2. So when we're doing our formula, we put the symbol for the element, and in this case capital O, and make sure you do it as a capital, and then 2. And to show that the two oxygens are joined together, the normal notation is that 2 is put as what's probably called a subscript, slightly below the symbol for the oxygen. So capital O and then subscript 2. In the same way, hydrogen has got two hydrogen atoms joined together, so it's H2. Nitrogen has got two nitrogen atoms joined together, so it's N2. Fluorine has two fluorine atoms joined together, F2. Chlorine, two chlorine atoms joined together, Cl2. Bromine, two bromine atoms joined together, Br2. And iodine, two iodine atoms joined together, I2. So these are molecules. Now, in terms of the periodic table, if you look at those elements that we've listed off there, there's the only ones where you've got two or more atoms joined together up to the end of GCSE. So these are the ones that we look at with GCSE. So hydrogen, as we saw there, was H2, and in the same way nitrogen, oxygen, fluorine, chlorine, bromine, iodine, and then we rarely study it, but also astatine. Those have got a 2 after them. So the unshaded areas, you simply use the formula for the element. So if we were picking out manganese, it's simply Mn. If we were picking out lead, there's lead there, Pb. If we were picking out calcium, Ca. But if you're representing the elements, then hydrogen would be H2, nitrogen, N2, and so on. So the shaded areas represent elements that have molecules with two atoms joined together, and they've got a formula X2. The proper term for those, so we'll introduce you to the name for those, and at GCSE we'll put this as a formal definition. Those are what are called diatomic molecules. Now it sounds as if it's a bit of a mouthful, but think of what they are. So the molecule was two or more atoms joined together. Di is a prefix that's used quite a bit in science, meaning two, and then atomic atoms. So putting the bits together, di, two, atomic, atoms, molecules, where you've got two or more atoms joined together. So these are diatomic molecules, where there's two atoms, and we'll see what that term covalent means with GCSE. That's the way they're joined. So a diatomic molecule is one with two atoms covalently joined together, and those are diatomic molecules. So when it comes to the elements, sometimes you might be asked the formula for the elements, and that's where you go and look at your periodic table. And those white areas that we've represented there, those you simply take the symbol for the element. So silicon Si, silicon's over here, so it's simply Si, or titanium Ti. But any of the ones that are shaded in green there, if you're asked for the formula for those elements, you put a little 2 after them. So hydrogen is H2, nitrogen N2, and so on. Okay, so if it was just elements, we'd be very limited in the amount of substance we have in the world, and we know compounds exist. And a compound is when two or more elements are chemically joined together. So formulas represents the number and type of atoms joined together. So here's 3 examples of compounds, and these are ones that we'll quite often come across at GCSE. So ammonia, NH3. Now the reason it's NH3, it consists of 1 nitrogen atom and 3 hydrogen atoms joined together. So capital N for the nitrogen, capital H for the hydrogen, and then a small 3 to show that the 3 hydrogens are joined to the nitrogen. This is another one. So 1 carbon joined to 4 fluorines. So it's carbon chloride. So normally when we put the formulas down, we put it in the order of the name. So carbon first and then 4 chlorines. So CCl4. So 1 carbon joined to 4 chlorines. And again, you'll notice capital C for carbon. Chlorine is capital C small l, so take your time and put that in correctly, and then 4 of those, so CCl4. Hydrogen peroxide is this molecule here. We've used that a few times in junior form, for example, to make oxygen in year 9, we use that, and it consists of 2 hydrogens joined to 2 oxygens, so it's called hydrogen peroxide. So hydrogen and oxygen. So we put in that order H and then O. 2 hydrogens, so H2, 2 oxygens, O2. So H2O2. And you can pick that out very quickly when you look at it that they must be compounds, because when you've got a molecule as a compound, there's 2 different types of atoms there. If you look back on our elements, there's only 1 type of atom present. So compounds are where 2 or more are joined together. Again, these are molecules because we've got at least 2 atoms joined together as well. So there's examples of 3 molecules from compounds. So the formula for a substance then tells us the type of atom present, and it tells us the number of atoms of that type. And we were again, in year 9 did a little bit of this, and we'll get to do a wee bit of practice with the questions on page 6 of the handout. And you'll see, for example, PbBr2. So what does that tell us? Well, Pb is the symbol for lead. If you go back to your periodic table, you'll see the symbol for lead there. And Br is for bromine. So PbBr2 tells us 1 lead atom joined to 2 bromine atoms. Pb joined to 2 bromine. Sulfuric acid is H2SO4, so break it down. H is hydrogen, so 2 atoms of hydrogen. S is sulfur, 1 atom of sulfur. And O is oxygen, 4 atoms of oxygen. So this consists of 2 hydrogen atoms joined to 1 sulfur atom and 4 oxygen atoms. So before you go on, pause the video and try the questions. If you printed off page 6 of your handout, try those. If you didn't, I'm going to put these up on the screen so you can let it run for a second or two, and then you'll see the questions come up, and then you can pause it and then let it run on for another few seconds, and question 3 will come up as well, and that'll let you do it without having anything printed off. So there's questions 1 and 2, so pause that and try those. And that's question 3. So again, pause that and try those. Okay, so moving on, reacting particles. Now, when particles react, the reason that we looked at those formulas is really what we want to try and get at GCSE is balanced symbols equations. We want to be able to see how the particles react together. And chemical reactions, when they're being represented, are represented by what are called balanced symbols equations. And the idea of a balanced symbols equation is that you're showing nice and clearly what's happening during a chemical reaction. So in chemical reactions, basically one set of substances are rearranged. So when you look at all of the examples we're going to do in the rest of this video and then your examples, look on the left hand side and you'll see that all the substances on the left hand side will react together, and they'll turn into the substances on the right hand side. Now when you've got these, all the atoms of the reactants, the things on the left hand side, are still present on the right hand side. They've simply been rearranged. So the substances which react together are called the reactants. The substances which are made are called the products. So the general scheme is reactants turn into products. And in a balanced symbols equation, all the atoms in the reactants are still present in the products. They're simply rearranged. And a lot of the work that we'll do at GCSE on balancing equations is to make sure that the atoms that are on the left hand side are balanced by the atoms on the right hand side. So let's look at a couple of examples. Carbon reacting with oxygen. So there's the symbol for a diagram of a carbon atom, and there's an oxygen molecule. See, there's two of them joined together, so we've got an oxygen molecule. And they turn into carbon dioxide. Carbon plus oxygen gives us carbon dioxide. So we can write that as a word equation that describes in words. But what we've got on the screen here is how the particles behave. So there's a carbon atom, there's an oxygen molecule, and there's a carbon dioxide molecule. So in terms of symbols, symbol for carbon is C, symbol for oxygen is O2, and then the symbol for carbon dioxide would be CO2, one carbon joined to two oxygens. So this then becomes a symbols equation. C plus O2 gives us CO2. And you'll see that this is what's called balance because there's two oxygen atoms there, they're joined together. There's two oxygen atoms over on the right hand side, they've now joined with the carbon. There's one carbon here, there's one carbon there. So that's a balanced symbols equation. C plus O2 gives us CO2. Here's one that usually, if you're in school, we'll have done this in the lab, where we take some limestone and we heat it. And limestone is basically a big molecule. So it consists of calcium, carbon and oxygen all joined together. And when we heat that up at the temperature of about a Bunsen, we shake those molecules. And if you imagine we had a model of a molecule and we just shook it, it would be likely to break. And that's what happens. The molecule breaks apart. And what it does is it breaks down here between that carbon and that oxygen and then turns into these two particles. So this is calcium carbonate, and when we heat it, it turns into this. Now if you look at what it is, it's calcium joined to oxygen, so that'd be calcium oxide, and then this. And do you recognize this? CO2, carbon dioxide. So calcium carbonate turns into calcium oxide and carbon dioxide. Now, in terms of symbols, let's put all of these together. So this is, can't get my pointer up there. Let's see if we can get, there we go. Okay, so this is calcium, one carbon, three oxygens all joined together. So the formula for it is CaCO3. So one calcium, one carbon, three oxygens. On the right hand side, one calcium joined to one oxygen, CaO, and carbon dioxide, CO2. And again, that becomes a balanced symbols equation. One calcium over here, one calcium here. Now on this side there were three oxygens all joined in this one big molecule. On this side there are still three oxygens, 1, 2, 3, but now they've been rearranged. One of them's on this and two of them are over here. And then one carbon joined to the big molecule, one carbon joined to the two oxygens over here. So again, this is a balanced symbols equation. All the atoms that are present on the left hand side are present on the right hand side. Now, something slightly different. Hydrogen reacting with iodine. So here's hydrogen reacting with iodine, And you'll be able to tell me that hydrogen plus iodine gives us hydrogen iodide. And there's what hydrogen iodide molecules look like. So when we make hydrogen iodide, there's only one hydrogen can join with one iodine. So this is a hydrogen iodide molecule. And because we had two hydrogens over here and two iodines here, that meant that we could actually make two molecules of this. So in terms of a balanced symbols equation, H2, this is I2, and then this is HI, this is also HI. So let's put them down. So H2 plus I2 gives us HI plus HI. Now, we don't like this. This looks a wee bit messy. And in maths, you know that if you're writing, for example, x plus x, you can make that simpler because x plus x is the same as 2x, or x plus x plus x is 3x. Now, in chemistry, we borrow the same idea. If you write the same formula twice, we don't like putting that in. So we'll put a number in front of it. And that obviously is going to be a 2. Now, we've got to be careful. The 2 has to not confuse with these ones. These small subscript 2s, remember, showed atoms joined together. So we want to make sure that it's different from that. So the way that we put it is, we first of all make sure it's a big number. You see that these are little small subscripts slightly below the symbol there. This is a big number, and it sits in front of the formula. And what that means is that 2HI means we've got two molecules, 1, 2, with the formula HI. And then this becomes our balanced symbols equation. So this tells us that H2 reacts with I2, and it gives us the molecule HI, and we get two of them. So hydrogen H2 reacts with iodine I2 to give us two HI molecules. Let's do a couple more examples to get used to this. Sulfur dioxide reacting with oxygen. So sulfur dioxide is SO2, so there's our formula for sulfur dioxide. Here, there's our molecule. There's oxygen. And when these react together, this sulfur can take an extra oxygen, and it can turn into molecules that look like this. And that's what's properly called sulfur trioxide, sulfur and 3 oxygens joined together. So oxygen plus sulfur dioxide gives us this. Now, let's look at the formulas for this. O2 would be the symbol for oxygen, so we're going to put that down in a second. This molecule is SO2, as is this molecule. It's also SO2. And then on the right-hand side, what we've got are two molecules, 1, 2, and they've got the formula SO3. So we'll write out in full. O2 plus SO2 plus SO2 gives us SO3 plus SO3. Now, again, we don't like this. We've got SO2 plus SO2, bit like X plus X. So let's shorten that down to 2SO2. We've got SO3 plus SO3. Again, we don't like that, so let's shorten that down to 2SO3. So there's our symbols equation there. And it becomes O2 plus 2SO2 gives us 2SO3. And then this becomes our balanced equation. Okay, another example, hydrogen peroxide decomposing. So here's hydrogen peroxide molecules, and whenever they basically bump into each other in the correct way, they become water, which is this one, and oxygen. Now, again, let's look at our formulas. So our formula for hydrogen peroxide, we come across it earlier on, 2 hydrogens and 2 oxygens, and we've got 2 of those, so let's write down H2O2 plus H2O2. That gives us 2 water. Now we know that water is H2O, so H2O plus H2O plus O2. And again, we're not very happy with that because we're writing the same formula twice. So rather than H2O2 plus H2O2, we shorten that down to 2H2O2. Rather than having H2O plus H2O, 2H2O and oxygen. And once we've put that down, that then becomes our balanced symbols equation. Now again, pause and take a look at it and see everything that's on the left hand side, all those atoms that are on the left hand side, 1, 2, 3, 4 oxygen. We've got 1, 2, 3, 4 oxygen on the right hand side. they're simply rearranged. And the 4 hydrogens, 1, 2, 3, 4 that are on the left-hand side, 1, 2, 3, 4 on the right-hand side. So these become balanced symbols equations because the atoms are present on the left and on the right, and all that's happened is they've become rearranged. Okay, and the last thing to do with this is you'll see on pages 7, 8 and 9 of the handout, there are some examples to do the same thing. Now, when you go to do your examples, we really just want this as the final equation. This is what we're really after with the big numbers in front of it. If you find it easier to do that first of all and then put it down, do it. But most of you will be happy enough just writing down the formula H2O2, for example, and then counting the number that there are, putting the 2 in front of it. Write down the formula H2O, counting how many there are, and put it down. And that way you should end up with the balanced symbols equation. So try those examples, 7, 8 and 9, and then send me a photograph of them. For those, as we had said on the assignment, that can't print it off, I'm going to show you it now on the video. So again, what you can do is run it for a second or two and then pause it each time you've got it. So there's examples 1 and 2. There's 3 and 4. Five and 6. Seven and 8. And 9 and 10.